Okay, blank canvas here. Topic for this particular video is integration. If I can spell it, yep, integration. Oh my goodness. Let's try that again. By substitution. This technique typically gets referred to as U-sub or U-substitution. That U is the variable we end up working with. So we've got some basic techniques with integration, right? So for example, the integral of x with respect to x, we know that that's x squared over 2 plus c. All right, so that's a basic technique of integration. All right, the integral of secant squared, let's go with theta, d theta is tangent of theta plus c. And another one, how about the integral of, let's go 1 over, let's go with the Greek letter, phi, d phi, doesn't matter what my variable is, that'll be ln of the absolute value of phi plus c. So there's some basic techniques there, but what would we do, for example, if we got, I don't know, say an example like this, the integral of sine of x times cosine of x dx. Well, that's interesting, right? That's a product of two functions, and we haven't run into a product of two functions and having to find its antiderivative yet. So I'm going to take you through the why of this thing called integration by substitution, and then we're going to execute it on example D here. So I'm going to leave myself a little bit of space for example D. Example D, of course, will require this method of substitution. Okay, so why do I need this? Well, if you ever get an integral where you have the product of two functions, right? If the first function, this f of g of x, is related to the second function in the following way, where a portion of the first, if we take the derivative of it, we get the second, right? What we can end up doing is in essence rewriting a function h in terms of u. And then once we get this form, we can use basic techniques to integrate. So it's really like it's a method to kind of simplify the integral in terms of another variable and allow us to use some more basic methods in order to evaluate, right? So let's talk about how this will work mechanically. Okay, so what we end up doing, right, is what we want to do is we want this variable u to equal g of x. And the reason for that is because when I differentiate both sides, I get du dx is equal to g prime of x. Now our goal, our end result, as you look over here, is to get all functions and variables in terms of u alone. So I want to find a way to substitute and to rid myself of anything x related. Okay, so first of all, let's take a look at this. I've got f of g of x, right? I'm going to replace g of x with u. And really, as I look at this, I probably should have used f over here instead of h. Right? I'm going to write f in terms of u, not in terms of g of x. Okay, so I'm able to do that, right? I can take this integral right here and simplify the f of g of x as f of u. Okay, now how do I get rid of g prime of x and dx? Well, what I'm going to do is I'm going to do a slight manipulation here and solve for dx. So dx is going to end up equaling, with a little bit of work, that'll end up equaling du over g prime of x. Okay, so now what I'm going to do is I'm going to sub in for dx, du over g prime of x. So I've not been able to rid myself of the g prime of x underlined in blue here yet. So I'm going to leave that where it is. Right, so I have g prime of x, and then in for dx, I'm going to plug this du over g prime of x. So I get du over g prime of x. All right, so now as I simplify, you can see the g prime of x's will disappear, and I'll get f of u du. Now, of course, I go back to my basics, my basic integration techniques, and I'm good to go. All right, so let's see how that works up here in example D. Okay, so f of g of x. What is f of g of x? Well, f of g of x is actually not a composition of two functions. You could think of it as that. I could think of, let's say, f of x as x and g of x as sine x. So f of g of x would just be sine x, right? Now I'm going to think of g prime of x as cosine x, right? Because the derivative of sine is cosine. So what I'm going to do is I'm going to set u equal to sine x, so du dx is equal to cosine x. Now what that allows me to do from there is I can solve for dx. All right, dx, and actually what I would do here is I wouldn't do a whole lot of anything there. I would actually write du is equal to cosine of x dx. So I can replace cosine x dx with du, and I can replace sine x with u. So I've got the integral of u du. Let's repeat that. I replaced cosine x dx with du right there, and I replaced sine x with u. Now I know for sure that me personally, I can integrate u du. I actually just did it up here with just in terms of x. Well, that's going to equal u squared over 2 plus c. Now, after you get done with the basic technique of integration, what you do is you go back and you sub back in what u was. And in this case, it was sine. So the antiderivative of sine x times cosine x is sine squared x over 2 plus c. It's a basic example with integration by substitution and kind of a breakdown of the y. All right, let's go ahead and jump into the notes for whatever section number this is. I can't even remember.